In this video, we're going to talk about the shape of the derivative. We know that for a function f of x, the derivative of the function f prime of x is the same as the slope of the tangent line at x, and it's also equal to the instantaneous rate of change at x. We're going to focus on the shape of the graph of the derivative based on the shape of the graph of the original function. So let's look at the graph of f of x below. We're going to draw a sketch of f prime of x based on f of x. But let's first estimate the values of the derivative at a few points. So we'll find f prime of negative 2, f prime of positive 2, f prime of 4, and f prime of 5. Okay, so here is the value x equals negative 2. We're thinking about the slope of the line tangent to the curve at that point. We see that the slope is going to be a negative number. This is just an estimate. It doesn't have to be absolutely perfect, but we're thinking about the rise over run of this function. It appears that when this function goes down, that's 9 units in y, it goes over 1 unit in x. So an estimate for f prime of negative 2 would be about negative 9. Then for our next value, f prime of 2, so here is 2. And f prime of 2, we want the slope of the tangent line at that point. We see that the tangent line is doing something like this. We don't know, again, this is just an estimate, but it looks like maybe for every 1 that it goes over in x, it goes up 3 in y. So f prime of 2 could be estimated at about 3. What else do we want? We want the derivative or the slope of the tangent line at x equals 4. So here is 4, and here is the tangent line to the curve at that point. We see that the slope of that curve is 0. The change in y over change in x is 0 because this is 0 change in y. So f prime of 4 is approximately, is 0. And last one, f prime of 5, we're about there, or we are there. And so what is the slope of the tangent line at that point? The slope of the tangent line at that point is also going to be a negative value, but it's not quite as large a negative value as this one. So f prime of 5, let's see, it looks like for every 1 it goes over in x, it's going down about 4 in y, so maybe about negative 4. So those are estimates of the derivative of the function at a few points. So let's use that to graph our derivative f prime of x. Okay, we could start by plugging in a few of our points that we found. So we found that f prime of negative 2 was a really small negative number, negative 9, plug it in down there. We found that f prime of positive 2 was 3, so maybe we could plug something in about there, 1, 2, 3. And f prime of 4 was 0, so f prime of 4 is 0, and f prime of 5 is negative 4, so f prime of 5 is negative 4. This is just a sketch. It doesn't have to be absolutely perfect. We just want an idea of what the derivative is doing. What are some other things we can observe? So we saw that f prime of negative 2 was a large negative slope, that the derivative at this point was large negative. What's happening around there? So it's still continuing to be a negative slope, but not quite. It's the magnitude of that is decreasing. So hard to say exactly what's happening here, but maybe something like this. It's becoming less negative, so it's becoming closer to 0. Where does it shift? It shifts right here. So f prime of 0 is also 0. So it's becoming less negative, less negative, less negative until we get there. Now after x equals 0, we see that we have a small positive slope to begin with, and then it becomes a larger positive slope. So this is a slope, maybe here it's like 1/2. So it's becoming a small positive number, then a large positive number. We estimated the slope here to be about 2, so that's this right here. So we're going up and reaching there, and then at that point it's still a positive value, but it's becoming a smaller slope and then hitting 0. So going down, still positive but smaller. And then here is where we hit a slope of 0. And now our slope is negative. So now our slope is negative, and we are going down this way. So it's very messy, but this is, a very messy estimate of the shape of our graph. A general rule of thumb we see is that when f of x has a negative slope, f prime of x, the derivative, will be negative at that point. If there's a point where f of x has a positive slope, then the derivative will be a positive value at that point. And if f of x has a slope of 0, or if the tangent line to the function is horizontal, then the derivative at that point will be 0. So I'll let you try a few examples. So for those 3 functions below, sketch a graph of each of the derivatives, and for each of those also estimate the derivative at the value x equals 2. So try each of those out. We'll talk about them in just a moment. All right, let's take a look at our first example. So we know that when the function has a slope that's negative, the derivative will be negative at that point. When the slope is positive, the derivative will be positive at that point. When the slope is 0, the function will be 0. The derivative will be 0 at that point. I often like to start off with this and see, are there any places where we've got a horizontal tangent line? Here there are 3 such places. So here, here, and here. Those are all places where the tangent line to the curve is horizontal. So there are horizontal tangent lines to the curve at each of those points. So those are places where the derivative is going to be 0. So there, and there. So a little bit after 1, right around 3 and just before 5, our derivative, the graph of the derivative, will be 0 at each of those points. Okay, what else could we say here? Before that point, so f prime of x is greater than 0 over this interval. So before that point, f prime of x is greater than 0. The slope is positive on all those values, and it sort of starts as a really large positive value and then is coming down. So, maybe we're starting with some really large positive value and then coming gradually down. For the next part of the graph, we see that now the slope is negative. We've got a negative slope here, and it starts as a smaller negative value, and then the slope increases until we get to that midpoint. So maybe we've got negative value and then coming back up because the slope again was negative, sort of reaches a peak negative point down here and then it becomes less negative, is coming back up this way to meet us at that next 0. Then we are starting with a small positive slope, which becomes a larger positive slope and becomes smaller positive again. Like right before that 0, it's becoming a small positive value. So we've got the same kind of thing going on, maybe something kind of like this. And then we hit this horizontal tangent line and start going downwards. So we've got this negative slope that is increasing, so maybe something like that. So this is a graph of our derivative. So this is the derivative. This is just an estimate, a sketch. It is not perfect by any stretch, but we've got, these basic premises filled that when the slope is negative, the derivative is negative, and some idea of sort of scale. So when it's a large negative slope, it will be a large negative number, and so on. All right, let's take a look at this simpler function. If we want, the one above, we don't know exactly what that was, but this one is pretty obvious. This is just the function f of x equals -2. So, here's negative 2, and at every point the function is the same. It never changes. So never changes. What then is the rate of change? Well, it never changes, so the rate of change would be 0, never changing. And if we think about the tangent line to that curve, it's basically just that. It's a flat line, and it has a slope of 0. So what is the derivative of this function? The derivative of this function is simply the function 0. So f prime of x, the derivative of this function is simply 0. And I just realized I forgot to find f prime of 2 for this function and the last one. For this one, f prime of 2, pretty simple. It's just 0 because f prime of x is 0 at all values of x. For the previous one, if we're looking at f prime of 2, so here's 2, f prime of 2, we're estimating it, and that's, again, that negative slope, and looks like for every, so if we're thinking about that, maybe for every 1 we go over in x, we're going down about 3 in y. That's just an estimate. So maybe f prime of 2 is about negative 3, and that's, again, just an estimate. All right, last one. So again, this function is also pretty easy to see what it is to estimate. This is definitely a linear function, so it's linear, and for every 1 we go over in x, we're going up 3 in y. So f of x is just the linear function, 3x. And if we think about the tangent line to this curve at any point, the tangent line to the curve is just the line itself. So what is the slope of this? The slope is 3. Again, for every 1 we go over in x, we're going up 3 in y. And that's the same no matter where you look. The slope is unchanged. A linear function has constant slope. And so what does f prime of x look like? Well, 1, 2, 3, it is just the constant function 3. F prime of x is 3 at any value of x. So that is what the graph of the derivative of this linear function looks like. And if we also want to find f prime of 2, the derivative at 2, then that is 3.